Okay, now square root, simplifying. Remember, punching it into your calculator is not simplifying. That's if I had to solve an equation with it and all that. Eventually, when you solve equations next year, you'll have to use this strategy because they will not accept the decimal, but that's here nor there. Okay, all right. Square root of 81, oh bam, I know that equals 9. It's a perfect square. It's going to have just number at the end. Okay, the square root of 17, obviously 17 is not a perfect square. Now, is it divisible by 16? I think not. Is it divisible by 9? I think not. Is it divisible by 4? I think not. That means it is prime, and we circle it. Okay, 108 between these two. So I take 108 divided by 100. Nope. 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 49. You just got to keep working your way up until something works. Now 36. There we go. So I make this into a factor of 2 factors of square roots, and the number we got is 36. Now, if you don't know what other number goes here, it's real simple. What's 108 divided by 36? Well, I did that, and I got 3. So square root of 36 equals 6. So it's 6 with a square root of 3, otherwise known as 6 square roots of 3. All right, now for the back page, simplifying some expressions. Now this is just a square root, but it's got variables and exponents in it. So I want to make each factor have its own square root. So I have the square root of 16. I have the square root of x to the third, and I have the square root of y to the fourth. Well, 16 right away has an equal. It's 4. Oh yeah, by the way, you should make a square root at the beginning. Now, if that had an equal, this 4 will go outside. You will have no big factors inside. No coefficient factors will be inside. Okay, so out. Whoops, I wrote on the back paper. So that's out. Okay. All right, x to the third means 3 factors of x, and I'm grouping them into 2's, and anything left would stay in the square root. So how many groups was I able to circle? There is 1 circle, so x to the 1 power, not 1x either, it's to a power. And then we put this x was in the square root next to it. Okay, so x to the 1's out, x is in. Okay, y to the 4th. Okay, double those up. How many pairs did you make? You made 2. And there's none left over. So if there's none left over, that's going to be out. Okay. And that's simplified. 4x, or x to the first, y to the second, with a square root of x still. Okay, multiplication and addition. Again, they ain't even close to doing the same thing, okay? The strategies that you use to simplify it are nowhere near similar, okay? They're not even close. You shouldn't even compare them. If you had one of those Venn diagrams, you would hardly have any in the middle at all. So multiplication, 1 and a 2 and a 3. Think of that as a 3-step process. Well, I know I got to multiply 3 and 2. Those are both outer factors. I make my square root and multiply the 2 inner factors, so it would be 20 times 2. Okay, all right, now 40. Nope, that's not a perfect square. I think most people know you can't divide. 40 is not divisible by 36. 25, no, it's 1.6. No. 9's not going to work. I'm pretty sure 4 will work. Okay. Okay, so I got this to work out. So I drop my 6, and then I make a product of 2 square roots. Okay, and I know that 40 is divisible by 4. So 4 was the number I got. And find this other number. What's 40 divided by 4? You're breaking it up into multiplication, but you take 4 times what's 40? Well, it's 10. 40 divided by 10 is 4 is 10. Okay, and the square root of 4 is 2, so we replace this with its equal. And 6 times 2 is 12 with a square root of 10. All right. Next one is an addition problem. Again, it's not, again, adding two numbers of different square roots is like trying to add 4 x's to 3 y's. Doesn't work, can't do it. Okay, so what you need to do, what you can do with square roots is, like when you have letters, you can't make the letters the same hardly. But, well, there's ways to, but we need to make the number under the square root the same. And also, I want to go back to this one. If I couldn't have divided this 40, let's say that if that was another number like a 30, if you can't divide it by anything, then you stop here and that's the answer, okay? Because you can't simplify it down any more than it already is. But all right, so square root of 2. Well, right away I know 2 can't be divided by any of these. Come on, man. And no, 2 divided by 4 is not 2, okay? 2 divided by 4 is a decimal. It is 0.5. It is a half, okay? So I'm going to circle this because that's already the simplest form. Now 18. 18, not 16. 18 is divisible by 9. 9 is a factor of 18, so I make this into 2 factors. So it's 9, and 18 divided by 9 is 2. Again, 9 times what's 18? Oh, it's 2. So I get rid of the square root of 9, and I know that it has an equal of 3, and 4 times 3 is 12 with a square root of 2. Okay, guess what? Now the square root number is the same. Now you don't want to add 2 and 2. You get it the same so you can write it down and say, okay, it's like I have 3 of something and then 12 more of the same thing. 3 plus 12 is 15. Okay, now those dreaded triangles. They're 2 problems, but they're different. Okay, I find the 3 trig ratios of the angle theta. Again, that's T-H-E-T-A is how that's said. And theta, what it's known as, is kind of a referencing point. So we need to find the sine of theta, the cosine theta, and the tangent of theta. And we need 3 ratios here. And I'm going to flip this over so I can remember what's what. A way to remember it is SOHCAHTOA. SOHCAHTOA. If you're not much of a speller, that probably isn't going to be great. Well, TOA is pretty easy to know. Ka, C-A-H. Okay, so I know that my sine is the O over the H. I know that my cosine is the A over the H and O over the A. Now, all these need to be replaced with values. Okay, so across from the right angle is my hypotenuse. Okay, that has a value of 23. So I know all my H's are going to be 23. Doesn't really help me on tan because hypotenuse isn't part of the tangent. Okay, then I find that theta sine. If I can, I have one here, and that is the O. Okay, so O is 18. So anywhere there's an O, I know that has a value of 18. Okay, now the A I don't know. So there's one thing I don't know in this out of the 3 sides. So whenever it's 1, I can use my Pythagorean theorem. A to the second plus O to the second equals H to the second. Okay, so A. Yeah, I don't really know A, so there's my X right there if we don't have A. O, well, I know my O is 18, so 18 to the second power. And H, I know my H is 23 to the second. Okay, so not much I can do about X to the second at this point other than solve for X. But I need to get the second powers off the other bases. Okay, so 324 23 to the second is 529. Okay, see these two? We don't add them. They're on opposite sides. We need to get this out of here over here. So minus 324. So that one again, you only add if you have numbers for A and O. Okay, if you have H and then one of the other ones, no, you're subtracting. Okay, so 529 minus 324 is 205, and then I find the square root of 205. Okay, 14.32. And that's the A, so every A has a value of 14.32. Okay, so those are all my ratios. Again, don't worry about reducing the fractions. That can come later. Not in here. Okay. Find the three sides and three angle measurements. So here's where I will find my sides. Here's where you find angles. The angles are easy. I could pretty much do it now if I felt like it. 90. And I also have 33 degrees. And another thing that I've been asked, not recently, don't ever use 90 degrees as a reference angle. No, never. Okay, 57. All right, now the easy part's out of the way. Let's go to the hard part. Well, I got to know what sides and what I know. So here's my H. Yeah, I don't know that. Okay, there's no theta sign. There's a reason for that because you already have a degrees in there. Okay, I'm going to circle it, and that is known as my reference angle. I'm going to put 33 degrees. Now, it's important to have off this side, very helpful. And across from that's my O. So my O I actually know. I know that's 15 units long. Okay, and then the A, I don't know that either. So again, that's two of these. I'm not sure how long they are. So I can't use a Pythagorean theorem. That only works when there's one you don't know. Now there's two, so we want to use ratios for that. Now on the ratio, before I worry about anything else, I'm going to put that reference degrees, 33. And I'm not saying you want to, you kind of have to, okay? It should go right there. Okay, now here's how I set up the rest of it. The sides I don't know are A and H, so I need to put A on one of them, H on the other, but not together in the same one. Okay, then I'm going to team that with the side I do know. So AO, HO. Okay, so A and O, what would I want to use for A and O? Well, not sine, not cosine. Oh, there's A and O. It'd be tangent, so tan over 1. But one thing I see people do a lot, they'll put A over O just because that's the order they wrote it down. No. The tangent function is always the O over the A. Okay, so I know O. I know that's 15 units. A, I don't know that one. That's X. Okay. And to find the X, here's the X, diagonal from here. So I want to multiply those. So I need to take 1 times 15, write that down, divided by tan 33. So 1 times 15 divided by tan 33, and that's going to be 23.09 or 23.10, and that's my A. If you want to put 0.9 because you like that better, whatever. Now you got to understand that H should end up being the longest side. If the H ain't the longest side, something's amiss. Okay, so H and O. Okay. So that would probably be the sine. There's O and H. So sine. We want to put 1 in the denominator. That's going to be O over H. So OH. Okay, so O I know is 15. H, that's one I don't know. Okay. All right, so here's the X. So I want to find this product here. So 1 times 15 after that product has been found, which is 15, I know it is, but we all have to divide by the outer factor of the sine of 33 degrees, okay? 1 times 15 divided by sine 33, 27.5, okay? And just as duly noted, the hypotenuse did end up being the longest. Again, I don't draw my triangles to scale, okay? But the H is always the longest no matter how you draw it.